Thanks for joining us. We'll have some questions at the end, so I'll try and give you an update as to where we're at inside the Webb School of Engineering, what departments we have, what programs we offer, what skill set you need to be successful, and the sorts of opportunities you might expect to encounter while you're here on campus as a student. So the Webb School of Engineering is relatively new. It's about 2 years old, and it was set up by the split of math and computer science into two separate departments. Computer science joined the Webb School of Engineering, and at that time we also created a new department in electrical and computer engineering. So there are in fact two departments now inside the Webb School of Engineering. They are computer science and electrical and computer engineering. And between them they offer degrees in computer science, a concentration in cybersecurity, and we also offer electrical engineering and computer engineering as separate degrees. I'll get back to that a bit later. The good thing is all of those programs are relatively closely related. So unfortunately at school, many students don't quite know what an engineer does or what a computer scientist does, and they sometimes think, oh, I'll go learn computer science, that way I can be a games programmer. Then they discover it's not quite what they're after. The good thing is these programs are actually relatively closely related. And so we've structured things so that it's fairly easy to move between one program and the next during your freshman year without any loss of credit. So you can still graduate in 4 years. After that, they truly become separate kinds of disciplines, and it would be a little harder to do that without loss of credit. But definitely the freshman year, it's easy to migrate. So the way we do that, the way we succeed in making sure that happens, is that you have some shared classes in that freshman year. Computer science is a little less heavy on the science and math. So if you're thinking that you might want to switch or you're not sure where you want to be, starting in engineering is often the best choice because it has the more strict math and science requirements, and it's always going to be easy to transfer those into computer science. If you start in computer science and you were to want to move to computer engineering, for argument's sake, then if that was a possibility, I would suggest you take the higher level math and science to be able to do that if you wanted to. But otherwise, as I said, they're fairly closely related, and migration between the programs is pretty straightforward if you need it. The School of Engineering is located in Couch Hall here on campus. The building was recently renovated about a year ago, and we have been able to get state-of-the-art equipment to support all of the programs. So, for example, with cybersecurity, we spent a fair amount of money buying an environment that allows students to get hands-on experience, build secure networks, attack each other within that room, for example, and do that with state-of-the-art equipment that allows us to simulate almost any kind of threat that you would like, allowing the students to get a real understanding of cybersecurity. Similarly, computer science has state-of-the-art equipment for teaching computer science, and engineering, as it's being rolled out, has state-of-the-art engineering equipment to support that program as well. So you'll learn techniques and skills on these equipment pieces that will make you very valuable to employers, that will allow you to put into practice the theory that you learn in class. You'll also find that throughout the school, we've got very caring and very accessible professors. Our concern is your education. So your faculty will know you by name. You will be in small classes, typically of around 20 students. So you work closely with your peers and you work closely with your faculty member. As I say, they know who you are. If you don't come to class, we'll know and we'll chase you up. If you're struggling in class or you have questions, they're available to you during class, after class, in their offices. They enjoy having students come to see them and have a conversation about what you're learning in class. Our goal is to provide you with a hands-on education. That's an overused term, but for us, what it means is you'll understand the necessary theory and so forth that forms the foundation for each of those disciplines. And then you'll have the opportunity to put that theory into practice on the equipment and so forth that we have, so that you can build things, be it a software artifact or a more physical artifact using, for example, a 3D printer or a computer-controlled router or a laser cutter, for example, just to build a physical representation of whatever your project might be. But generally speaking, the professors are there. They are your friends. They want you to come to them if you identify any difficulties or challenges or something isn't making sense. But their goal will be, as I say, to put the theory and so forth we learn in class into practice so that you know exactly where that theory is relevant, know how to use it, know how to deploy it, and you gain the necessary practical skill set that you need to enter industry or move on to grad school. As a student in one of our departments, you also have access to a variety of clubs and activities. It's a great way for you to socialize with your peers, to pursue your interest in computer science or in engineering, and to put into practice again what you learn. For example, our innovator in residence on campus is Steve Wozniak. Steve is one of the co-founders of Apple, and Steve was recruited to become our innovator in residence, and he is on campus at least once a year interacting with the students. He sits down with them, answers questions, gives them talks. But what's important is that there is a group, which we call the WOZ project, that works on a project. Recently, they've been working on building a autonomous golf cart to drive around campus. And Steve Wozniak acts as an advisor to them, not necessarily telling them how to build it, but telling them about opportunities and encouraging them to become innovative, to try different things, not to be afraid to fail, and to put their skills into practice and to have confidence in themselves. They can do it. It just takes some perseverance, and it takes some ingenuity in some cases. Another really great thing and a distinguishing feature about the programs that we have here at High Point is that the computer science and engineering programs are obviously technical programs. They are technical disciplines. You need to have some technical skills to be successful. But High Point provides you with a liberal arts education to supplement that. So you'll get the necessary technical skills that you need, but you'll also learn a bunch of non-technical skills. And they will include things such as communication, critical thinking. You'll learn maybe some business skills along the way. You'll learn how to reason. You'll learn some interdisciplinary skills because you'll be working on interdisciplinary projects. You'll learn some ethics. These are incredibly valuable skills that employers look for. Don't underestimate the context that surrounds the education you're getting in your major. So for us, your major is going to provide those technical skills that you need to be successful in your chosen career. And then the liberal arts education surrounding that provides you with all the scaffolding that you need to have those soft skills, if you will, to be able to interact with others, think sensibly, communicate effectively, and become a useful member of a team, all of which you'll be doing inside a job. So let me tell you a little bit about the majors that we have and what each of them does, what their salaries are roughly, and what their growth potential is in terms of the job market. Let's start by having a look at computer science. Computer science has a single major. It has a Bachelor of, well, it has two majors really. It has a Bachelor of Science in Computer Science and a Bachelor of Arts in Computer Science. The difference between them is the amount of technical content. The Bachelor of Science in Computer Science is the one we would recommend for someone who's choosing to be a professional in the discipline. However, some students would like to pursue a double major. The Bachelor of Science makes that a little bit tight in terms of the requirements that you need to satisfy. So the Bachelor of Arts has slightly weaker math and science requirements to make room for additional business classes, for example, if you wanted to do a double major, say, with business. What does a computer scientist do? Well, if you ask people when they come out of high school and they haven't seen computer science before, they may argue that computer scientists play games. In reality, computer scientists develop programs. They're software engineers. And what a computer scientist does is builds some kind of software artifact to solve somebody else's problem. All of the programs in the Webb School of Engineering are not self-serving. There are very few problems that are, say, computer science-centric. In general, computer scientists and engineers take somebody else's problem, build a solution for that, and then deliver that to the end user. So typically we solve someone else's problem. The computer scientist is going to solve a problem for someone by building a software artifact. A computer engineer, for example, is interested in the hardware-software boundary. So they're looking at chips and telecommunications and so forth, and they are looking at ways to control that with software and to have that work. And then the electrical engineer is more interested in the hardware side. So the example I like to show people is look at a device like your cell phone. If you look at that device and you see a device that basically has a battery, consumes electricity, there's a bunch of circuitry on the inside, if that's your interest and your passion, you probably want to pursue electrical engineering. If you see a device that has a whole bunch of hardware, but it runs software to make things happen, and you can control the behavior of the hardware through software, etc., then computer engineering is what you're typically interested in. And if you see a device here that holds a bunch of applications and solves your problems by basically giving you access to those apps so you can use those, if that's your interest is writing those apps, that's typically computer science. And if your interest is making this device secure so other people can't hack into it and your data is safe, then cybersecurity is typically what you're interested in. We offer all four of those. So computer science, as I said, is about building those software artifacts, the pieces of software to make the applications run. Cybersecurity is all about building safe and secure systems. That includes software systems. So for example, your banking application on your phone, we don't want that being hacked or your data stolen. We also don't want the hardware to be attacked or a source of vulnerability. So we need to be able to have a secure operating system. So even cybersecurity has an overlap, say, with computer engineering. Computer engineers are interested in basically building the circuitry. They're interested in some telecommunications. They're interested in making that software control the hardware. They're interested in the operating system, that whole boundary where software meets the hardware. That's their forte. They know a little bit about electrical engineering, they know a little bit about computer science, but they know a lot about making the two of those areas come together to actually solve problems. And the electrical engineering folks are the ones who build the hardware for us. They build the componentry. They're interested in building, say, antennas for telecommunications, building devices such as your battery for long life. They're interested in all the physical components that you typically see in a phone. So that's an example that hopefully gives you some understanding of the difference between them. In essence, if you're interested in building software, computer science is where you want to be. If you're interested in hardware, electrical engineering is where you want to be. And if you sort of sit in the middle and you do a bit of both, computer engineering might be for you. The salaries in each of these areas are actually comparable and extremely good. If you have a look at the Department of Labor Statistics website, you'll find they have something there called the Occupational Outlook Handbook. And that handbook lets you know what the Department of Labor Statistics thinks job growth in these areas are and what typical salaries are. So starting salaries for graduates in computer science and engineering is typically in the 60s to 70s. Median salaries over your career typically are around about 100,000. And by the time you're retiring, many people are earning in excess of 100,000 a year with each of these degrees. Job growth is very strong in all of these areas. It is particularly strong in cybersecurity. That also means that job salaries in cybersecurity are also particularly high. It's your typical supply and demand curve, if you will. And so with strong demand comes strong salaries and strong job growth. So I think the Department of Labor Statistics was predicting somewhere in the order of 26 to 30% growth in cybersecurity in the next 10 years. And it's obvious if you read the newspaper, there appear to be hacks onto Google or Yahoo or Home Depot or all sorts of other sites almost on a daily basis. We need to know how to keep our systems secure, how to keep our data secure. So huge growth potential there. Computer science still sees very strong growth. It's in the 15 to 20% range, and electrical and computer engineering are typically around 10 to 15% growth over the next 10 years. So great areas to get into, great areas for job security, great areas for employment opportunities and for decent salaries. So from my point of view, of course, I'm a little biased, great area to get into. They are a little bit of work. I won't lie to you. The degrees are challenging. There are certainly easier degree options around, but I would argue that the reward and the job satisfaction you can get in computer science and engineering is very high. Your average working life is about 40 to 45 years, and you want to be doing something you really enjoy. So computer science, electrical engineering, computer engineering are going to give you a job that has variety, it has challenges, it has interesting things to do, it allows you to work on problems, it allows you to solve problems, and it allows you to help make the world a better place. And all of those are interdisciplinary, so you'll work together in a team. It's not slide beer and pizza under the door to keep you happy. You'll be out there interacting with the client. You'll be out there interacting with other people in the organization to try and build either a software product or a hardware product, or both, that solves a problem and delivers a solution to a problem. Either way, leads to a rewarding and very interesting career. Both of the programs, computer science, sorry, all three, computer science, electrical engineering, computer engineering, are also great preparation for grad school. So if you think that getting a master's or a PhD might be in your future one day, then an undergraduate degree from High Point in any of those three areas is also great preparation for getting into grad school and excelling there. We also have a 3+2 program in engineering, and this is for those people who are interested in areas, say, such as biomedical engineering, which we currently do not offer. You can do that in a 3+2 arrangement by taking 3 years at High Point and 2 years at Virginia Tech. There's also some summer classes you would need to take at Virginia Tech. But if you really want to come to High Point, enjoy the great atmosphere we have here, the beautiful campus we have here, there is a mechanism for you to do that with a 3+2 program. However, we do offer our own programs in computer science, cybersecurity, electrical engineering, computer engineering, so the 3+2 program is not available in those disciplines. But if you want to do mechanical engineering, civil engineering, biomedical, for example, then currently the 3+2 program is available as an option. Where are we going in the future? Well, we eventually will build a new engineering building, and at that point in time, we hope to start offering both mechanical and civil engineering. And I also hope to offer biomedical engineering at that point. We are also looking right now at taking cybersecurity and taking it out of the computer science degree, where it's currently a concentration within that program, and making it a separate degree in its own right. And we are looking at introducing a data science degree to possibly start in 2021. So lots of exciting things happening here inside the Webb School of Engineering. If you're currently a high school student and you've got opportunities to choose classes still before you finish high school, what classes should you take? I would strongly recommend taking some science and math classes. Science and math is the foundation for everything that is in computer science and engineering. And basically that forms that foundation. We build on that and give you a set of skills, and then you apply those skills and your understanding of science and math to solve facts, to solve those problems and deliver products. What personal characteristics would you like, or would I like to see in you? A natural curiosity would be great. People who are successful tend to be naturally curious and will try things out. They're not afraid to fail. Failure is just part of learning. Failure is just part of the whole product development life cycle. So try things out, see how they work, learn from them. Being persistent is important. If you're, for example, debugging some code, it may take a bit of perseverance and some persistence to find that bug and eradicate it. You also will be working in interdisciplinary teams typically. So you want to be working with people. You want to be able to communicate with people with different backgrounds, with different skill sets, and work together to solve a problem. That means you need to be a good communicator. It means you need to learn to listen. You need to learn to voice your opinion, and you need to learn to compromise and look for the best solution. The best solution is typically not the first one you think of, but the one that comes out after discussion with one of these interdisciplinary team meetings. You'll be a problem solver. As I said earlier, engineers and computer scientists solve typically other people's problems and build systems to help make their life easier. And most of all, you want to make people happy. You want to make the world a better place. You want to make a difference. Computer scientists and engineers do that. So hopefully that gives you some idea about computer science, electrical engineering, computer engineering, what kinds of careers it might lead to, what kinds of skills you might need, what sorts of salaries are available, and what people in each of those areas are primarily interested in. All of them are great opportunities for you to succeed in the workplace. All of them give you hands-on experience, putting a good balance between the theory and the practice so that you're never going to be left behind as the technology changes. You'll always understand the theory behind it. You'll understand how to adapt and change over time. There's one thing I can promise you is that nothing is going to remain static over the next 40 years. These are rapidly changing areas. Huge amounts of disruptive technology comes along, and you get to be at the forefront of that. You get to be able to employ that, build new products, and as I say, move things along and make the world a better place. It's really exciting. And we look forward to you joining us as a student here at HBU.